Hi everyone, my name's Andrew. I'm the head of content here at Mathspace. If you've ever done anything in Mathspace, if you've ever done a question, if you've done a lesson, if you've looked at an image, if you've played with one of our applets, then that's something that my team and I have put together. We read all your feedback. So if you happen to have ever sent any feedback as a student, please know that we do read it, and we work all the time to try and make sure that you've got some really great questions to work with. This is quite experimental, doing Mathspace Academy teaching through Mathspace, but I have some background in teaching. I taught at the University of Sydney for 8 years, and during that time I did a lot of teaching online and recording my classes for students. And I'm really excited actually to put my teaching hat back on and have some direct contact with students just like you. So if you're from New South Wales, that's good news. I am going to be looking at what is called the standard course for New South Wales. But if you're not from New South Wales, everything that I cover today and for many classes to come is going to be content that you are going to need for your course as well. If it ever does come up that it's not particularly applicable for some states, I'll let you know. Everything that I'm going to show you and work with today is going to make a lot more sense if you're logged into Mathspace as well. If you log into Mathspace, you'll be able to see the kinds of questions that I'll be looking at and the things I'll be discussing. So if you don't have a Mathspace login, ask your teacher, they'll be able to organize one for you. As I mentioned, these classes will be recorded. I've got the URL there, mathspace.co/academy. The chat, I've got it up on the screen here. I've got it here just to see how it goes. I won't be making a determined effort to keep track of the chat at all times. I'll just probably let it scroll by. But if you do want to chat amongst yourselves, then go ahead and use the chat feature. If you'd like to ask a question of me and you'd like me to respond, then use the Q&A feature on the bottom of the window where you can see my face. There'll be two little bubbles that say Q&A. If you open that up, it'll send me through a question, and I can either answer it or dismiss it, or even answer it privately as well. Okay, so that's the housekeeping items. If you have any questions, then throw them in the Q&A section. And next up, what I'm going to do is I'm going to go into my student account and show you what I'm going to be looking at today. So let me just pull this over across. Here I am, David Bowie dinosaur, best avatar. And this is my dashboard. You've seen this many, many times before. I'm going to be looking primarily at two different sections of Mathspace. I'm going to be looking at the textbook, and I'm going to be looking at the topics. I actually think that topics is the best place to start whenever you're doing work, especially if you're doing work on your own. If I go into the topics page, I've got the New South Wales Maths Standard 11 textbook selected over here. I'm going to zoom in a bit. There we go. New South Wales Maths Standard 11 2020. If you don't see New South Wales Maths Standard 11 there, maybe you're out of state, or maybe you were looking at a different textbook, then you just click on this button here, select Australia, New South Wales, and then select New South Wales Maths Standard 11. So one thing that you might not know is that every school teaches maths in a different order and at different pacing. Some schools start with one topic, other schools start with a different topic. And so I decided for today that a good way to start everything off would be to start by looking at the formula and equations topic. Formulas and equations is something that I'm sure you've looked at sometime this term, or if you haven't, it's been a part of your mathematical journey for many years. Formulas and equations just keep on coming up and coming up. I wanted to make sure that we have a good grounding in the things we're going to be using, the basic techniques that we're going to use across all the other topics across Mathspace. If you know your formulas and equations, you are going to have a much easier time of everything else in the course. Whenever I interact with students and they're having difficulties with perimeter and area, or they might be having difficulties with data or with interest, a lot of the time we can trace that misunderstanding down to some misunderstanding that occurs here at formulas and equations. So if you click on formulas and equations from your own topics page, you'll see what we call the subtopics in Mathspace come up. This topic happens to have 7 subtopics. If you open up any of these, you'll see there's a scorecard. If you've ever done any work on Mathspace, it'll appear here. There's a question set if you want to pick questions out for yourself. There's a lesson if you want to read the lesson. And then there's practice. Practice will let you earn mastery in the subtopic. And I think that the best thing you can do, aside from, of course, doing all the work that your regular teacher sets you, is to master each of these 7 subtopics to make sure that you have all of the foundational groundwork covered. Then you can go and start working on some of these other mastery bars. By the end of year 11, hopefully all of these bars will be filled up and you will have mastered the entire course for year 11 and you'll be ready to move on to year 12. But the first topic is definitely the natural place to start. Okay. For me, whenever I'm trying to master a subtopic, I like the topics page because the topics page lets me just click practice and I go straight in and I can start doing some questions. And if you want, you can start practicing, or maybe you've loaded up the topics page already and you've noticed that you're only at 80% or 50% or maybe only 10% and you want to start pushing those up. You just click that button and you'll be immediately able to start earning mastery. But in order to present today's lesson to you, I'm actually going to switch over to the teacher view. The teacher view is very similar to the view that you can get by clicking on textbook. I'm going to click on textbook here. And once again, it says New South Wales Maths Standard 11 up in the top left. If it doesn't say New South Wales Maths Standard 11 for you, you can click on it and you can select a textbook for yourself. Find New South Wales Maths Standard 11 and click on it and you'll get this view. So why am I using this view rather than the other one? Well, when I click open formulas and equations, all of the questions are going to be displayed for me here. I can start an adaptive task just like I could on the topics page, but I'm not going to be able to see my progress here. Instead, the textbook's kind of like a regular textbook. You can take a look and open up each of them and see, oh, I want to do this question. So you can click on any of these buttons and try the question yourself, or click on Reveal Solution and it will show you the full worked solution for that question. So the textbook is much better for reference. When you're ready and you want to actually earn mastery and see how your mastery is going, the topics page is definitely the best, but because I'm presenting to you and I'm hopefully going to teach you a few things, I'm going to be using the textbook page. So I'm going to switch across to my teacher account now. And you can see I might have some extra little buttons and you get a little peek behind the curtain, but it's just so that I can select the questions and go from there. Okay, so take that away and let's grab this window instead. Okay, so here I am with my teacher account. So as I said, we're going to start with formulas and equations. What I'll do is I'll take a look, I'll describe what each of the subtopics are trying to achieve in a kind of a broad fashion, and maybe look at some of the questions as well. So at the beginning, we're talking about evaluating algebraic expressions. So a good example of what evaluation means is when we construct a model of something, we'll usually use pronumerals or variables to express something about it. So on the screen here, you can see a square. This is any old square. Now, I can change the zoom of my window. I can zoom in, and that's a big square, and then zoom out, and now I've got a little square. It's taking a little time to catch up with my zoom levels, but I'm just calling each of the sides here M. The perimeter of the square is 4M, whatever M happens to be. If I want to find, like, what happens if one of these side lengths is 6? Well, I evaluate this formula by substituting M for 6. I put a 6 where the M is, and it just tells me the perimeter straight away. It's the whole point of creating algebraic expressions and equations in the first place, so that we can use them. If instead the side length was 10, then I put 10 where the M is and do the evaluation there. So let's take a look at an example. This is our video recording environment. So unfortunately, you won't have access to this. It's the perks of working for Mathspace, that you get to look at things like this. But what I've got here is a regular Mathspace question. If you look throughout the first topic, you'll be able to find this question and do it yourself. Okay, so what have we got going on here? The volume of a sphere can be calculated using this formula. So I'm going to write it out. It's almost always a good idea to write a formula yourself before you start using it. So here we are. I've got V equals 4 on 3 pi r cubed. Lots of crazy stuff going on in this question. So I'm actually going to do some highlighting here. So I've got V, that's standing in for the volume. I've got a fraction, so this fraction over here. I've got pi, which is the symbol that we all know and love, standing for the circle constant. And then finally, over here, I've got r cubed. Okay. The basic idea behind this equation is that if you know one of these letters, if you know either r or v, then you'll be able to find the other one. And this works no matter what value of r or what value of v you're using. Now, in the question here, we've been told that the radius has a value of 2. We can write this as r equals 2 over on the side here. Whenever we do a substitution, we take this equation and we replace this letter with this number in the equation overall. So all I'm doing is replacing r with 2. Whenever I see r, I'm going to write 2. Okay, let's do it. V isn't r, so I'm just going to rewrite it. V equals isn't r. I'm just going to rewrite that. 4 on 3 is not r. I'm going to write that again. 4 on 3. Pi isn't r. Pi. R cubed. R is r. Well, okay, I got to do something with this one. So I'm going to replace r with 2. Replace. All right, 2 cubed. So now I've got this formula, and notice that everything over here on the right-hand side is a number. Now, this guy here, pi, it doesn't look like a number, but it is a number. It's just impossible to write out using the digits 0 to 9, so we use a Greek letter instead. The important thing is that the thing on the right is a thing that you can put into a calculator. I like to use Google's calculator because it's right here in my taskbar. So I'm just going to open up a new tab real quick, and I'm going to put this in so that Google can do the calculation for me. So I'm going to do 4 on 3 in a bracket, and I'm going to multiply that by pi. I'm just going to type pi, and then I'm going to multiply that by 2 to the power 3. So I want to draw your attention to a couple of things. Notice that I've done a bracket around the 4 over 3. I've got times pi, and times, each of those times I'm using a star, which is shift 8. It also works in Mathspace. And then the power is that, it's called a caret. It looks like this, 2 to the power 3. I hit enter. Thanks, Google. 33.51 is my answer. So that's how I knew I was done. It's the kind of thing that you can throw into Google and get your answer. You can use your handheld calculator if you want as well. And then I click on my answer here. Answer. There we go, 33.51. So just to recap, I've got a formula. I rewrite it. I write it myself because it's always good to write the formula you're about to use. I'm told something like the radius is 2. I replace the letter with the value I've been given, and then I work to make sure that I can put this into a calculator. All right, this was just to get us started. Let's move on to the next one. We can get rid of this calculator too while we're at it. Okay. Similar situation. We've got an equation and it's got 2 letters in it. Let's read it out. The relationship between F degrees Fahrenheit and C degrees Celsius is blah, 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 some equation. Solve for the temperature in degrees Celsius C that is equivalent to 51.8 degrees Fahrenheit. I know what you're thinking, why Fahrenheit? Well, it's really the Americans' fault. They all the time use Fahrenheit and they just drag us all along with them. So let's do it anyway, just in case you ever have to have a conversation with an American. Okay, once again, I'm going to write F equals 1.8 C plus 32. There's my equation. And I'm going to do some boxes around each of the components so I can talk about each of them. So F, that's standing in for degrees Fahrenheit. Then I've got my 1.8, I've got my C, and I've got my plus 32 at the end there. Okay. I've also been given in the question that Fahrenheit is 51.8 degrees. So just like I did before, I'm going to write an equation over here, F equals 51.8. And this is what I'm going to be substituting into my equation. So just like I did in the last question, whenever I see F in the original, I'm going to write 51.8. Okay, let's do it. F, that's F, 51.8. 51.8 equals. And then the rest, none of these are F's, so I'm just going to write it again. 1.8 C plus 32. Okay. We are in a similar place to where we were last time. At the beginning, we had an equation that had 2 letters in it. After we did the substitution, we have an equation and it only has 1 letter in it. It means that we can now solve for C. But I can't put this into a calculator. Before, it was V equals a whole bunch of numbers. So that's what we're going to try and do here. We're going to get C on its own. If we have C equals something, and that's something we can put into a calculator, we're done. Okay, so how do we unwind this expression? I'm going to use my colors again, just so you can see what I'm talking about here. So I've got my 1.8. We've got our big goal. This is what we're trying to get to, our C. And finally, the plus 32. Now, in mathematics, plus always happens before, after any timesing. What that means is that if I was to put C, something in for C, I'd multiply it by 1.8 before I added the 32. So to unwind this expression, you always start by unwinding any addition before you unwind any multiplication. So I'm going to subtract 32 from both sides. Minus 32. minus 32. And 51.8 minus 32 is 19.8. 19.8 equals 1.8c. It's looking a little better. The last thing I need to do is I need to divide by 1.8 to get c on its own. C equals 19.8 divided by 1.8. All right. And this is definitely something that you can put into a calculator. So let's do that real quick. As I said, Google is our friend. 19.8 divided by 1.8. Answer, 11. Oops. I'm going to click on the answer there, and I can see that up over here. So what was different about this question? I started similarly. I've got an equation. It's got more than one letter. I did a substitution, and now it's only got one letter. Whenever you've got an equation and it's only got one letter, it's looking good. You just need to rearrange it to make sure that its letter equals something you can put in your calculator. And that's what we've done here. Rearrange it so that you've got something equals calculator, throw it in, and you're away. With those two ideas in mind, the two I discussed in those last two questions, the first three subtopics should be ready for you to get started on. Make sure that you read the lesson. You can access the lesson either by accessing it through the topics menu or through the textbook menu. And you can see how we evaluate algebraic expressions. If you got a little bit lost in any of the explanations that I gave just now, then take a look at the lesson, and then you can always take a look at the questions, open them up, look for their solutions. And same thing with solving linear equations. That was that Fahrenheit Celsius question I just showed you. And then equations arising from substitution, very similar to the one that I just looked at. Okay, let's move on to the next question. This one is similar to the previous one, but there is one difference. I'm just going to give you a second to read the question and see if you can see what's different about this one. So there's a substitution in here, just like there was in the previous one. But this time, we're going to have to do the substitution in more than one place. You may have thought it was a bit silly at the beginning when I was like, whenever you see an R, write a 2, and I went all the way through from left to right. It's going to come in handy now. So as I said before, it's always good to start by rewriting the equation that you're about to use. 3k plus 4 equals ak minus 2. And k equals 6 is going to be my substitution. So in this time, whenever I see a k, I'm going to write a 6. All right. So I'll rewrite it. 3, 6. Hold on. It's not 36. Something in algebra that we do to save time is that we write things next to each other to mean times, which is super confusing, but you get used to it. What can I say? So this is actually 3 times 6. There's a little hidden times in there. So I can't write 36. It's 3 lots of k, 3 lots of 6. So 3 times 6 plus 4 equals a, not a6, but a times 6 minus 2. And now we're in exactly the same situation we were in before. We've got an equation. We started off with an equation with 2 letters, 2 kinds of letters in it. We did the substitution. Now we have an equation with only 1 kind of letter. And we just want to rearrange this equation to make a the subject. So it's a equals something we can put in our calculator. All right. So to start off with, there are kind of different ways that you can go about this. You could do this arithmetic on the left. Let's start by doing that arithmetic on the left. You don't have to, but it'll make things a little cleaner. 3 times 6 is 18, and adding 4 gives me 22 equals a times 6 minus 2. Just like addition coming after multiplication in the previous one, subtraction's coming after multiplication in this one. So I'm going to be adding 2 to both sides. We're just going to color out plus 2 to get rid of that minus 2. 24 equals a times 6. And hey, we're not even going to have to use a calculator. Something times 6 is 24. What is that something? You can think about it as dividing by 6 as well. What's 24 divided by 6? A equals 4. So the thing that was different about this equation than the previous equations we were looking at is that we started off with 2 values of k. But we just substituted it in both places and we did the same process, just making it so that a equals something you can put into your calculator. 4 is something you can put into your calculator. It's pretty boring to put in your calculator, but you can put it in your calculator if you want to. Okay. Let's move on to the next one. Before, actually, I'll tell you what, let's talk a little bit about what's going on here first. I'm going to jump into 1.04. Maybe you've already mastered 1.03 to 1.01 to 1.03. And I'm going to talk about changing the subject of formulas. So let me find a question. So this is the textbook menu. If you haven't seen the textbook menu yet, this lets me take a look through the kinds of questions I want to look at. Because the next one's on gathering like terms. Yeah, that's a tricky one. I did have one prepared. There you go. Okay. Things get a little bit trickier when we start moving the letters around. In all the examples I've shown you before, we start off with more than one letter. We throw the values in for some of the letters. Then we kind of just leave one of the letters in place and move all the numbers around. But whenever we're changing the subject of a formula, we're actually going to be moving the letters around. And that's a leap in algebraic skills that a lot of students struggle with. But we're going to go through it one step at a time here. All right. Make m the subject of that equation. At this point, maybe you're asking yourself, what is this equation? Why would I ever want to make it the subject of the equation, make m the subject of anything? I don't even know what those letters mean. I think it's easy to get discouraged when you do mathematics because sometimes you can't see the point of what you're doing. But at the same time, if your coach, when you're playing sport, tells you to run around the oval 3 times, then is running around the oval 3 times gonna make you better? How often do you run around the oval 3 times exactly when you're playing sport? Or maybe they're gonna get you to do push-ups or sit-ups or something. Like, how many push-ups do you do in a game of netball? Like, doesn't happen. But what we're trying to do is we're trying to create exercises that will train the muscles in your brain that will help you engage with everything in the mathematical world. So if you are starting to think, oh, what's the point of this? I don't understand what all of these letters mean. Just remember, this is like doing stretches or some, I'm not, you'd be surprised to learn I'm not a very physically active person. I'm working on it. But these are exercises that we're doing. And if we can do these algebraic exercises and we're really fit in our minds, we can engage with the world in a mathematical way. And we can engage with everything in the rest of the course that we're working to master. So let's, with that preamble done, let's go back to the question. Make M the subject. Okay, let's just make sure we know exactly what we mean. Our goal is we want M equals blah. We want M equals a bunch of stuff. Left-hand side M, right-hand side everything else. The reason we might want to do that is in the future, if we substitute values into this right-hand side, then we can just get M out straight away. That's really the reason we'd be changing the subject. So let's start by writing everything out just as we see it. And I'll also mention that if you ever type in your formula, I'm going to do a question in Mathspace like this in just a second so that you can see what it looks like. It's just a lot easier for me to explain if I can write and doodle and draw colors and stuff. So what's going on here? Currently, what's the subject? X is the subject, because it's X equals blah, not M equals blah. So we got some minus 9K business out the front here, and then we have this bracket over here. I could individually box up the N and an M, but I'm just going to do it like this for the moment. Remember that writing things times each other is the same as writing them next to each other. If I want to get M on its own, I'm going to treat this blue blob just like I'd treat any number. If I wanted to move a number in this blue box over to the other side, I'd divide by whatever's in that blue box. We're going to do exactly the same thing here. I'm going to divide by minus 9K on both sides. Divide by minus 9K. Whether it was 20 or a bunch of letters or anything, it's something that is multiplying the box that has our M in it. All right, so let's do dividing. X divided by minus 9K equals, so I've moved this one over. I just can rewrite this, bracket N plus M. And we don't need to write the brackets anymore. The brackets were telling me that minus 9K multiplied all of this. So I can just get rid of those. Go. And I just have N plus M. Once again, imagine that instead of being an N, this was a number. So I've got N plus M. If it was 12 plus M, what would you do? Subtract 12 from both sides to get M on its own. We're actually just going to subtract N from both sides to get M on its own in the same way that we did subtract anything in this box. A 12, a 17, a pi, we just subtract it to get M on its own. M equals, I'm rewriting this guy, X over minus 9K minus N equals M. One final bit of convention for maths is that minus signs on the denominator can get really complicated really quickly. You've got minus, minus, so many minuses. The goal is eventually to have this equation potentially be something that we can find useful, something we can use to model something, something we can use to think about something. So minus signs on the denominator just complicate things. Minus signs on the denominator, you can move them out the front. So my final answer is going to be minus X over 9K minus N equals M. We could do some complicated cancelling if the top also had a minus, but just if there's a minus on the denominator, you just move it out the front. And now it's M equals blah, I've reached my goal. Great job. Okay. So I'm now just over half an hour in. I've gone through a couple of questions. that should give you an overview of the kinds of skills. If you're sitting there and thinking to yourself, I know all of this is easy, no problem, great. The best thing you can do is head over to your topics page and prove it to Mathspace. I'm just gonna bring up my student page once again and show you how that works. Maybe some people have joined late. Here's my student page, David Bowie dinosaur, best avatar. And here I have my dashboard. It's what you see when you log in. And if you click into the topics page, make sure that you have New South Wales Maths Standard 11 or the appropriate one for your state selected. And the first one should be formulas and equations. Go ahead and prove it to yourself, to your teachers, everybody, that you're all the way across this. If something is a little bit uncertain, if you don't quite get it, then maybe start at the beginning. Take a look at the kinds of questions by opening up the question set and see if you're ready to practice that set. So I've gone through 1.01 through 1.04. I will take a look at some of the problems down in this bottom half. And in general, when we do these classes, I will be focusing on between 2 and 3 subtopics and trying to be a lot more thorough with my treatment. I just wanted to make something that everybody could have access to and would be valuable for everyone for their first session. So before I continue on and take a look at some of the questions in this bottom half of the topic, if you do have any questions, please use the Q&A feature to ask me a question. If there's something that you'd like me to do, if you want, maybe there's a question that you'd like me to go over, maybe there's a question that you'd like to see me do in Mathspace, then just hit me up in the Q&A session. I'll give you a few moments just in case anyone's interested. All right. Let's go back and see what's next on the menu. Okay. This next question is going to be asking us to do what's called gather like terms. Once again, we're solving for x. So we want to make it x equals something. X equals something we can put in our calculator. But the tricky part here is that I've got more than one x. And it's not like that question I did before where there were 2 different values of k. And I could just substitute a value in for both of them. So what do I do? Well, I'm going to start. If you find yourself in this situation, the first step is going to be all x on one side. Now, it might not be x for any particular problem you're looking at. Maybe it's y or z or whatever it happens to be. Got to get all the x's onto one side of the equation. At the moment, it's on 2 sides. And a lot of the time when you look at an equation, this will already be true. But this is the extra step we're going to do. Which side doesn't really matter, but you can accidentally make things a little harder for yourself. How do I move the 6x or the 10x? I'd use subtraction. And 6x is smaller than 10x. So if I subtract a small thing from a big thing, it's going to end up positive. If I subtract a big thing from a small thing, it's going to end up negative. Negatives are lame. Let's stick with positive. So I'm going to start by writing the equation out in full. 6x plus 9 equals 10x minus 3. And I'm going to subtract 6x from both sides. The reason I'm doing this is that you can think of them once again like blocks. So I've got this 6x block and I'm minusing, oh, that was lame. Let me just fix up that box there. Okay. X. I've got a thing, I want to move it, so I subtract the same thing and they'll cancel out. And then x will be all on one side, just like I wanted. So I know that what changes over here on the left. 6x minus 6x, they disappear. I'm just left with 9. What about this? Let's say you don't know. Let's just write it. 10x minus 3 minus 6x. Sometimes I like to think about it a bit more dynamically. You can think about this 6x moving across to the other side and swapping signs. You don't necessarily have to write it out like the minus 6 on both sides. So what do we do? These two expressions are what we call like terms. They both have exactly the same combination of letters. They both have x's. Minus 3, he's not invited. He doesn't have an x. If someone else came along and they were an xy, not invited. X squared, not invited. Got to have the same combination of letters. 10x minus 6x, we can combine those two together. And because they have the same combination of letters, x, x, we can combine them just by thinking about the other parts of it. So I've got 10 and minus 6. How do I combine 10 and minus 6? 10 minus 6 is 4. So in the x club, 9 equals 10 minus 6 is 4, and they're still in the x club. So I've still got the x there. And then minus 3. Cool. And now we just do everything like we did before. I've got 4 times the thing I want, minus 3. I've got to get rid of the minus 3 plus. Got to get rid of the minus 3 first. And so I will add 3 to both sides. Plus 3, plus 3. And 12 equals 4x. And once again, this is something that you can think about in terms of, oh, I'm going to divide by the 4, or just think, what times 4 is 12? What times 4 is 12? 3 times 4 is 12. X equals 3. It's at this point that I want to introduce a different idea. We could actually solve this a completely different way. I want to show you how. Maybe you haven't seen this before. Everything I've showed you is important. Understanding like terms, moving them around. But I want to give you an idea of what it means to solve an equation. And this trick can come in quite handy in all sorts of places. What I'm going to do instead is, I'm going to test some solutions. I'm going to test some values. I already know 3 works, so just pretend that we don't know that. Okay, what I'm going to do is, I'm going to try, okay, is x equals 1 a solution? I don't know. Let's try it. This left-hand side, what does it become? 6 times 1 plus 9. 6 times 1 plus 9 equals 15. Nice. 10x minus 3. 10 times 1 minus 3. 10 minus 3 is 7. 7 and 15 are different numbers. So, no. Let's try the next one. What about x equals 2? I put 2 in. 6 times 2 is 12, plus 9 is 21. 10 times 2 is 20, minus 3 is 17. 21 and 17 are different numbers. So, no. What do you think is going to happen when I put x equals 3 in? Hopefully you're paying attention. 6 times 3 plus 9. This is the x equals 3 test. 6 times 3 plus 9 is 27. 10 times 3 minus 3 equals 27. Oh, yeah, they're the same. And that's why this guy is a solution. So if you're asked to solve something, using the algebraic techniques is often mandatory. We're going to see one final example today where you've got to use the algebra. But sometimes trying some values to see how you can balance those two equations might actually get you there a little faster. Or at the very least, if you're in an exam situation and you've just gone to all the bother of doing the algebra and you found x equals 3, I cannot recommend highly enough taking your answer, substituting it back, and checking that it does this kind of thing. Because if it does this kind of thing, then you've made a mistake, and it's really good to correct that before you hand your exam paper in. Okay. So as I said, I've got one more to go. This is definitely the hardest one. All right. I'm just going to summarize my equation rules, and I'm going to, so there was one which we had before, which is all x on one side. And of course, it might not be an x, it could be a p or a k or whatever. And then we have make x equals some stuff. And this is something that you can put into a calculator. We did this step only at the beginning. In some of the previous questions, we had to do this first, all x on one side. We did this one before we could make x equal something you could put into your calculator. I'm going to put one up the top, which is no fractions. Oh. If fractions need to come back, they'll come back. But fractions are a huge pain when you're doing any sort of algebra. So before you do anything else, number one should be no fractions. Okay, great. There are fractions. What do I do with these fractions? Okay. Let's start like we always do by writing out the equation in full. 2x on 3 minus 2 equals 5x on 2 plus 4. Okay, let's focus on the first fraction. Let's look at this guy, this fraction. How do we make him not a fraction anymore? Well, to get rid of the fraction, we're going to multiply it by the denominator. But we can't just multiply that fraction by the denominator. We have to multiply everything by that. So I'm going to start by multiplying both sides by 3. Everything on both sides is going to get multiplied by 3. So to start with, this term in the red box, it goes the way that we want it to. 2x. Now we've got a minus 2, but it also needs to get multiplied by 3. Minus 2 times 3 equals. Over on this side, we're going to have to multiply everything here by 3. So 3 times 5x on 2 plus 3 times 4. So just to reiterate, the 2x on 3 became 2x because I multiplied it by 3. The 2 became 2 times 3. 5x on 2 became 3 times 5x on 2, and the 4 became 3 times 4. Okay. One fraction down, one fraction to go. If you like, we can do some of the multiplication to clean this up. So you might, instead of writing 2 times 3, you can just write 6. Instead of writing 3 times 4, you can just write 12. But I'm just going to leave all those multiplications in. So now when I take a look at this fraction, how do I make this not a fraction anymore? I multiply it by 2. But just like last time, it's not just one side I need to multiply it by 2, it's both sides. So what have I got? I've got 2 times 2x minus 2 times 2 times 3 equals 3 times 5 on x times 5x on 2 times 2. The whole reason we times it by 2 is that we can just write this as 5x. And then finally, plus 2 times 3 times 4. And we can tick off the first step. After I rewrite this, 4x minus 2 times 2 times 3 is 12 equals 3 times 5 is 15x plus 2 times 3 times 4 is 24. How much easier is this than this? So whenever you're working with fractions, I strongly encourage you to get rid of them. Multiply by all the denominators and make it so it looks like this. From there, we can then go on to step 2 and on to step 3. There are a couple of extra items to finish off your understanding of formulas and equations. There's an applied unit on driver safety and blood alcohol content, and another applied unit on calculating medication dosages. So if you are all the way across everything I've done and you're like, I'm so across it, maybe you've even mastered some of these ones at the beginning, then have a go at these applied sets. Make sure that you can take that knowledge and use it in a context that really matters. Because it's not just these two subtopics. Everything that I discussed today, we're going to be using that in linear relationships, in measurement and energy, in perimeter and area. In every single one of these topics, we're going to be using the skills that I discussed today. Next time, I'm going to be taking a look at the income and taxation area. We're going to be talking wages, salaries, leave loading, overtime, all important stuff. And we're going to be using the skills we learnt today. After the holidays, we'll then move into some of the other topics. So if you do have any questions or comments, please ask them in the question and answer section. And I'll wait a few moments just in case anyone does have any questions or comments they want to throw open to the group. And if you do have any suggestions, let your teacher know and they can get in touch with us at Mathspace. If there's something that you'd like me to cover, if something worked or didn't work, we'd love to hear from you. Just make sure that you go through your teacher so they can get directly in touch with us. Okay. So once again, the recording of today's session is going to be available at mathspace.co/academy. There will be weekly sessions run throughout term 2. And if you'd like to see me talk about a particular thing or talk about a particular question you had any sort of difficulty with, the best way to reach us, as always, is to leave feedback for us through the workbook in Mathspace. Okay, So thank you everyone for coming along. I will see you all next time after the Easter holidays.